Hi all, my name is Kashyap. My student ID is 47697091. Coming to the big data assignment, the task 1 tells about the program which begins by connecting to the MongoDB and retrieving the tweet dataset from a specified collection. It then analyzes a CSV file to write the extracted information to. For each set in the dataset, the program performs the following tasks. Extracted keywords uses NLTK to tokenize the tweet text and perform parts of speech tagging. It then selects all nouns as a keyword and joins them together in a comma separated string. Extracted named entities, the program which uses NLTK to perform the named entity recognition on the tweet sets using the nchunk function. It selects all the entities with labeled person, organization and location and joins their words together into a comma separated string. Extracted topics uses the WADR sentiment to perform sentiment analysis on the tweet text using the sentiment intensity analyzer function. Here is the code shown here, the task which I have performed, and after processing each tweet, the program writes the extracted information to the CSV file using the CSV dict writer function. Overall, the Python program which provides a straightforward and efficient way to extract and store information from a tweet dataset in MongoDB uses existing packages. With a few modifications, the program can be adapted to other datasets or sources of text data. Coming to the task number 2, the task number 2 which tells about the mapper function and the reducer function. Here is the codes I have performed, and the mapper function reads in each line of text and outputs a list of pairs where the key is a word in the tweet and the value is 1. The reducer function takes the key value pair as input and outputs a single pair where the key is the word and the value is the total count of occurrence of that word. Here is the codes, and this will run the MapReduce job on the input file tweets text and stores the output in the directory output. Here is the output which I have performed. The code in the input in the file, Python file. This is the output file I got. Coming to the task number 3, the task number 3 tells about the implementation which defines a list of cities to count tweets for in case of the Sydney, Melbourne, Brisbane, Perth and Adelaide. Then in the mapper we iterate over each line of input and check whether any of these cities appeared in the tweets text. If a city is found, we output a key value pair with the city name as a key and the value of 1. To run the MapReduce job, we can use the MapReduce command in Hadoop with the mapper_py and the reducer_py as arguments. Here is the code which I have performed, an output which I have got. Here the input directory containing the input files and the output directory where the output should be stored. Coming to the task number 4, the task number 4 import the necessary modules including sys, emma_job, emma_step. We then define the sort tweets class which inherits from emma_job. The mapper function takes each line of the input file and splits it into individual tweet elements. Here is the code, the description of the task number 4. The reducer function takes in the tweet IDs and their associated tweets and sorts the tweets by their ID. The sorted tweets are then yielded one by one with the none key to ensure that they are sorted by their IDs. Here are some examples of the MapReduce functions, the codes which have performed. Here is one of the example. These are the examples. Here are the examples. And finally, in the task number 4, we define the entry points for the program using the if name equals to main statement, which runs the sort tweets class using the run function. The command shows here. This is the map reducer job. Again in the task 4. And here is the one. And coming to the task number 5, which tells about implementing the TF-IDF algorithm for keyword extraction in tweet dataset using Dask. Coming to the approach, reading in the tweets dataset, we use the Dask read text function to read in the text files containing the tweets from the directory. Dask allows for distributed processing of large text files, which is useful for handling big datasets. Keyword extraction, calculating TF-IDF scores, extracting top n keywords are the main approaches in this task 5. Here are the codes given and the output which I have performed gives this one outputs. Coming to the design of this program followed a distributed computing approach using Dask, which allows for parallel processing of large datasets. The program was implemented in Python and utilized the Dask bag and compute functions to read in and process the tweets dataset. The TF-IDF vectorizer class from the scikit-learn was used to calculate the TF-IDF scores, and resulting data was stored in the Dask arrays. Dask arrays for efficient computation. The argsort method was used to retrieve the top n keywords from each row of the TF-IDF score matrix. Coming to the result, the implemented program successfully extracted keywords from the text of each tweet and calculated the TF-IDF scores. The top n keywords with their corresponding TF-IDF scores were printed out to the console of each tweet, providing insights into the most important keywords in the dataset.